welcome back. Um, think it's episode 9. My Wi-Fi's out currently, so I was like, what game can I play? Sudoku, and I can record as well. So we're doing number 9 today, which is the partial domino sandwich Sudoku. Rules, the sandwich. The numbers outside each row and column correspond to the sum of the numbers between 1 and 9 in that column. We've seen this before. So say for this, let's go for this 4. Between the numbers 1 and 9 in this row, digits have to sum to 4, and in this case it would have to be 4. But let's say in this column of 5, let's say this is a 1, this is a 9. Those two digits have to sum to 5, therefore it has to be a 2 and a 3. Or the 9 could be closer, and it could be a 5 in the middle. Pretty simple. Partial domino, we have also seen this before. A white dot, so this dot right here, indicates, between two cells, indicates that the neighbouring digits are consecutive. So let's say this is a 6, this has to be a 7. Or that's a 6 or a 5, because those two are now consecutive. Pretty straightforward. And it's only partial, so it means not all of the white dots are given. A black dot between two cells indicates that one is bigger than the other. Is twice as big, right? So if that's a 2, that has to be a 4 or a 1, because 2 is twice as big as 1. Pretty simple, yeah? Multiplication factor of 2 across a black dot. An X in between two cells indicates that the cells sum to 10. Okay, that's nice. 4 and 6. Like, 4 plus 6 is 10. Look at the maths we're getting here today. Or it could be a 9 and a 1, because that also sums to 10. And a 5, or a V, Roman numerals reading in my head, between two cells indicates that that they sum to 5, basically. So if that's a 2, that has to be a 3. And if that's a 1, that has to be a 4. Basically. And then not all dots, X's, and V's are given. Cool. So, let's get started. Why don't we? Okay. Okay, all these 5s, there's only 2 combinations that work on a 5, is a 1 and a 4, or a 2 and a 5. 1 and 4, or 2 and 3. There we go. And on a black, why black? On an X, they have to sum to 10, which means there's no 5 that can go on a 10. Actually, that tells us that's 1, 2, 3, 4, 5. Because whatever that is, this digit has to be consecutive. This is interesting. Okay. So the combos that can go on a black dot are 1 and a 2, a 2 and a 4, a 3 and a 6, and a 4 and 8. Those are the only combos that can go on a black dot. Okay, well that can't be a 1 and a 2, because we need to have either a 1 or a 2 here, right? Because let's say this is the 1, 2. This would then can't be 1, 2. It'd have to be 3, 4, and 3, 4 do not sum to 5. So that can't be a 1 or 2. So we'll just delete those from here. This is our pool. 2, 4. Let's say this is a 2, 4. That means this can't be a 2 or a 4. Which 1 and 3, that's not sum to 5. So that can't be a 2, 4 pair either. So this is either 3, 6 or 4, 8. Cool. Now can we remove 3, 6? No. Okay, I guess that tells us, right? Let's say that's a 3, that has to be a 7. Because that's to add to 10. 4 is a 6, 6. Yeah. A 6 means a 4, and 8 means a 2. Okay. Let's say that's an 8. We'll do that by, let's put that 8 in the top left. If that's an 8, this has to be a 2, and that has to be a 4. Which means we've got 2 and 4 in the box. They can't go there. Okay, that doesn't work. So that means that can't be an 8. And then that means that can't be a 2 now. Because then 2 would plus one of these digits would not sum to 8. That means that if that's not 8, that can't be a 4. Okay. I feel like we are making progress. Okay. Let's try to see disprove the other way. So that's a 4. That has to be an 8. That's a 4 to sum to 10. That has to be a 6. And we can still get a 2 and a 3 in here. And then that would have to be a 1, which means that would have to be the 2, and that would have to be the 3. Okay, that's how it would have to work if the 4's there. Okay, which does work, so we can't rule it out. Okay, we 100% have a 6 in here. Because either the 6 goes here with the 3-6 pair, or the 8 goes there, the 4 goes there, and the 4 plus 6 is there. So there has to be a 6 there. Ooh, let's look at this. Okay. This is basically no, I wouldn't say a cheat, helping hand, right? Like it tells you all the combinations of numbers that sum to 16 that don't include 1 or 9, because they have to be on the outside, right? And we just... Okay, given there's no 1 or 9 here, let's say we have a 1 here. Yeah, so you have to have at least 3 digits in between the 1 and the 9, right? Which means at least one of these digits has to be included, and given all 3... Yeah, so the one of the 1 or the 9 has to be on the top side, and one has to be on the bottom side, because there's no other way you can get 3 digits in between 1 and 9 here. Which means there has to be a 6 in it. So all these ones without a 6 can go. Okay, this 3, 6, 7 is interesting, because that means that we would have to have our 1 and 9 down here. And left a 3 and a 6 would work there. And if it goes 3, 6, 7, that would work. Okay, so that works. A 2, 6, 8 does not work, because then what would go here? Nothing, because that's either be a 3, 6 or a 4, 8. That doesn't work. And this 2, 3, 5, 6 also doesn't work. Because that means that 3, 6 would have to be here. And then there would have to be either a 6 or a 4 here to make... No. A 7 or a 4 to make this 3 or 6 add to 10. So that also doesn't work. Okay. So now we know it is a 3, 6, 7 combo. Which means there's no 8 in here. There's no 4 in here. Cool. And then we get our 3, 6 there, which means this can't be a 6. Which means this is our 7, and 7 plus 3 is 10, which puts our 6 in here. That 3 means that can't be a 2, because this has to sum to 14. Now that can't be a 1, also can't be a 4, because this has to be consecutive to whatever that digit is. And our 1 and 9s have to be here. Okay, let's get this. Ooh. Okay, what happened there? Okay, we're back. What do we do now? Okay, maybe this 12. Ooh, okay, we know there's a 1 in here. Okay. Okay, so we know, once again, we can't get 2 in between without using We know there has to be a 1 here. So if there's a 1 there, we could go up with 4, 8. No, we couldn't. Or 5, 7. We could do that actually. Just think about where we can place the 9 such that this 1 would work. Let's say we have 1, 4, 5, and that would have to be a 3 and then a 9. Using this 3, 4, 5. But if it's a 1 here, we have to go 1, 2, 4, 6, 9. Or 1, 2, 3, 7, 9. Or if it's here, we could also go 1, 4, 6, 2, 9. Ugh, it's just disgusting. That could be so many possibilities. The interesting thing I did see was this box, right? Okay, let's say we're gonna play this as a orange, right? Whatever this orange box is, let's say it's a 2, 3. That means 2 or 3 can't go in here, which means it has to be a 1 and a 4, which means this is the opposite of whatever this is. So if this is 2, 3, that's 1, 4, and if this is 1, 4, that's 2, 3. Okay, we just know the opposite. That's as far as we're going to get at the moment. Okay, obviously we're seeing here, right? It's a 5. So you could have 1, 9 on the outsides. And then obviously 2, 3 in the middle to make that 5. But you could also still have 1, 9 with a 5 in the middle. Yeah. Do you know anything about this? No, not really. This is surely... Oh yeah, okay, right. So a 10, given that you can't have 2 5s, has to include at least one of the low numbers, 1, 2, 3, or 4. So 1 with a 9, a 2 with a 8, a 3 with a 7, or 4 with a 6. Right, so whatever this digit is here must go in there. Right, so let's say let's just not make it blue, make it yellow. So whatever this yellow digit is, has to appear in here. Okay, also this can't be 1, 9. Because between the 1 and the 9, their digits have to sum to 4. And if this is 1 and a 9, there's obviously no digits in between. So given that this is not 1, 9, this is now either a 2, 8, a 3, 7, or a 4, 6. That looks really dirty. But given that's not a 1, 9, this can't be a 1, which means that can't be a 4. Sick. That gets us so many places. Okay. Can I prove that this is not a 1, 4? Maybe. If that's 1, 4, this would have to be 3, 6. Where to next is the real question. Cool. Okay, I think this column 12 will help us. If this is a 1, well, we also know 1 or 9 can't go. We know can't go there. but that doesn't help. Okay, we could also say there's at least 3 low digits through there. Could just be 1 low. That's the other way it works, right? There has to be at least, there has to be either a 1, 2, 3 or 4 on there. But I don't see that how that helps us at the moment. Okay, it's this 4 that helps us actually. So we know there's no 1, 9 there. It can't be there because 4 is the only thing that can go in between, right? And as we think about how this and this prevents us, right? We can't go over them. But this, we could have a 1 on here. If we have a 1 there, that means that has to be the 2. That means that would have to be a 9, and that would have to be a 4. That's one way that would work. But we couldn't have a 1 here, because that would have to be the 2 to get that to work, and then we can't put another 2. Right. So 1 could go there, but we could also just have that with a 4 in the middle. Right, this 4, that means the 4 can't go there. 4, 6, okay, cool. Okay, I don't know what I'm marking here. I think this line's hurting us. Okay, so now this has to be 2, 3, which means the 4 can't go there. Oh my god, it's been staring me at the face. Yeah, in the face for ages. That's a 2, 3, which means this is no longer a 2, 3. This has to be a 1, 4. And a 1, 4 limits that, no? So we can't have a 1, 2. We can't have a 2, 4. We can have a 3, 6. We can't have a 4, 8. So that's a 3, 6 pair. Up there. This 2, 3 limits that, surely, right? So we can't have 1, 2. Can't have 2, 4. Can't have 3, 6. But we can have 4, 8. Cool. So now we know this can't be... Well, this either has to be a 1, 2... or a 2... No, it can't be a 2, 4, because we can't have 4 in there. So it has to be a 1, 2 there. Because you can't have a 3 in it, and it can't have either a 4 or 8. So it has to be 1, 2. It can't be 2, 4, because the 4 can't go there. Because it has to be between 1. Okay, so that means the 1 is there and 2's there. That means there are 9's here to make the 4 in the middle, to get this to sum to 4, between the 1 and the 9. Sudoku, that puts an 8 there, 4 there, a 9 there, and a 1 there. That 4 puts a 1 there, a 4 there. Those have to be consecutive, that's a 5. And I see 1 and 4 here makes that a 2 or 3. And that 2 makes that the 3 and that the 2. That 3 okay, this is starting to work. Oh, given there's no 2 there, that can't be the 8. And we know this digit has to appear here, which means that's the 3. That's the 2. Wow, that just solved itself, basically. So we can remove all these colours now. Nope. Cool. What's next? Okay, that has to either be 1, 9 or 4, 6. Because 2 and 3 are here, and to get that to sum to 10, that's what we have to do. This can't be a 6, which means that can't be a 4. Oh, we've got a 1 there now. Okay, that'll help with this. So we could go 1, 4, 5, 3, 9. Or we could go 1, 4, 8, the other 4, 8, and 9 up there. Okay, the only one we've confirmed it's not. We can't go 2, 3, 7, can we? No, we can't go 2, 3, 7. And we can't go 2, 4, 8. No, we can't go 2, 4, 6 either. But we can still go 4, 5, 3, 9, or 8, 4, 9, or 5, 7, 9. Okay, cool. Wow. Look at that. That can't be any of the 4 low digits, because you can't be a 1 or 2 by Sudoku, so that has to be the 6, 7, 8, or 9. Obviously can't be the 9. Which means to get this to sum, we need a 4, a 3, or a 2. It can't be a 4. Which means that can't be a 6. Okay. I feel like we're starting to get somewhere. Oh, it'd be so nice if I could just put a 1 and a 9 there. Actually, I kind of almost can. Because the only 2 places now where where this 5 can be sandwiched between a 1 and 9 is there. Because that's 5. Or there. Actually, we could put a 9 there and a 1 there. And a 4. No, we couldn't put a 5 there, could we? So we can do that. The next possible is there, with a 9 being at the top and a 1 being at the bottom. Cool. Can we do that? Which means a 9 would have to be there, 1 would have to be at the top, but the 5 would be in the middle, and that's not possible by Sudoku. And that... would that work? No, because... if a 1 or 9's here, that means that would have to be consecutive, and that a 5 is not consecutive to 1 or 9, and that's the same reason here. Cool. So we know that it's either one of those, so either this bottom or that top, which means this has to be a 1 or a 9. Well, actually, it's the 9. And this, one of these, is the 1. With either a 5 here, or not a 5 there. Okay. I feel like we could do a bit of Sudoku in this middle box. The numbers we're missing are a 2, an 8, and a 9. Cool, we know the 8 can't go at the top, 9 can't go in the middle, and a 2 can still go anywhere in there. The 3, 6 means the 3, 6 has to be in there. The 6 has to be in there. And the 1 means the 1 has to be in there, so that's a 1, 6 pairing in here. Given the 6 can't go in those 3, and the 1 that's one of these can't go there either. Cool. Which means our last 3 digits here will be a 2, 5, and a 7. And obviously that can't be 5 and 7 by Sudoku. Okay, now in this massive column, our 2 digits we don't have are a 4. No, we do have a 4 down at the bottom. We don't have an 8 or a 9. And that can't be a 9. So that's the 8. And that's the 9. What are these then? We have a 1, a 2, a 3, a 4. We don't have a 5, a 6, or an 8. And we know that 8 can't go there. which means the 8's at the bottom. Oh, do we know there has to be 6 there, so that's the 1 and that's the 6. How did that become a 7? Right, because there's only a 7 or 8. Yeah, okay, so that's a 7, which means that's a 3 to get to something, to 10. And we should be able to know what this digit is. Because we've got a 1, a 2, a 3's in here, a 4, don't have a 5. And these last two to make out the box are a 7, 9. Cool. Like these are our next. Actually, let's do a bit of Sudoku. Number 1 has to go there. A 2. No real help. A 3. Oh, 3 has to go there. A 4. Nope. No help really. No help. No, those 8s don't help anything. And 9. Right, okay, that 9 there helps us actually with this 12. Coming down 9 can't be up there. So we have to go down with 4, 5. So 3, 9. Okay, that 3 then tells us that 3 has to go in there. Okay. 3, that makes that a 7 and a 3. Okay. Just get this back up. So we've done this sandwich, and this sandwich. Still need to do this one, but that's, we know the 1 has to go to one of the top 2. I want to look at this consecutive now. So possible digits for the top are a 1, a 2, a 3 can't go there, a 4 could go there, a 5, 6, 7, or an 8 or a 9. We're just looking purely Sudoku and forgetting that white dot's there. So it can't be a 1, a 2, a 3. Could be a 4. It could be a 5. Could also be a 6 or an 8. Okay, now obviously that can't be a 1 now, because 1 can't be consecutive to any of those other digits. That top one also can't be an 8, because 8 is not consecutive to any of those bottom digits. Can't be a 4, because 4 is not consecutive to any of those top digits. Cool. So we've got that down to a 4 or a 9. It's obviously 9, 8, or 4. That could be, nope, that can't be a 6. So 4 with a 5 or a 9 with an 8. Let's do the same again here. This can't be a 1, a 2, a 3. Oh, this can be so much more. I don't know if that's even worth it. That's the minimum. Okay, let's do it anyway. So that can't be a 1, a 2, a 3. It can be a 4, or it can be a 5, it can be a 6. Can't be a 7, can be an 8. This bottom one can't be, it can be a 1, can't be a 2, or 3, can be a 4, 5, 6, 7 or 8. Okay, so now these two need to be consecutive, so that can't be a 1. And the rest of those work. So that's got us nowhere. Maybe it's telling us where the 4 goes, because the 4 can't now is restricted to one of those two. But also still just doesn't seem like it helps us much. Maybe it's telling us about the 4 and this. Or another number. Because if the 4 doesn't... Oh, a 4 to go there, a 5 would need to go there. Which means a 1 would have to go up there. That's too tricky for my brain to process at the moment. Okay, this is a pair. What numbers are they? It is a 5, 6 pairing. And that can't be a 5. Okay, that 5 now eliminates those from being 5s. So that 5 has to go there. That makes that a 7 and a 5 over here. Fortunately, that doesn't tell us whether that's a 1 yet. Whether it's a 1 yet, does it? Okay, by Sudoku, that has to be a 2-9 pair. No, that can't be... What? That can't be a 2. That can't be a 9. What? Has that been staring me in the face a year? Okay, so that has to go like that. Okay, that makes that a 4. That makes that a 5. 5 can't go there, that's the 5. Okay, the 1 can still go on either side. That's annoying. Okay, now there's no 5. A 4 can't go in there. And that 6 is not consecutive to anything in the top box. Neither is that 8. So we know that's a 7 down there. With that being a 6 or an 8. Which means these... Actually, we know what this one over here is. What am I doing? 1, 2, 3, 4, 5, 6. It's a 7. And then these two have to be a 2, 3, 4, 5, or a 6. Which means these last ones are a 1 and an 8. Okay, let's go this one now. So it can't have a 5 or a 7, which means it also can't have a 6. So it's either an 8, 9. Wait, no, okay, whoa, let's slow down. So it can still be a 1, 2, 3, 4, 6, 8, 9 in there. That's a lot. But that can also be a 1, 2, 3, 4, 6, 9. That 9 could be that top 9 can't be consecutive to anything. Okay, cool. Also, the 6s can't be consecutive to anything. If only I knew what that was. Because that could still be anything down there. What numbers are missing from this one? We're missing a 2, a 6, and an 8. Right? 2, 6, 8. No, not a 6. A 2, 7, 8. And we know that can't be a 2. And that can't be an 8. Okay, let's just do some normal Sudoku now. Do you know anything about the 1? No. The 2. Not though we already didn't know. Well, we know the 2 has to be one of the top 2 then. Basically, the 3, oh, this feels almost 1, 2, 3, 1, 2, 3. Okay, we can place the last 3, which is now down this bottom corner. Yeah, right, so that's a 3 now, which means this has to be a 1 or a 2. Nope. This has to be a 2 or a 4. Cool. Let's keep that going, Sudoku. Yeah, 4 has to go one of those 2 up there. Has to go there. 6. Seven. Let's go down here somewhere. That doesn't help. An 8. Oh yeah, okay, 8. I can't go there. That's the 8. So 8 has to go there. 9. Okay, we know 9 has to now go there. Which means this has to be where the 9 is, up here. And we, from earlier, the 4 had to go in one of those 2. Which means that's our 4, and again makes that our 1. Okay. This is looking like it's about to crack. The 9s. That 8 means that can't be an 8, that means that's the 8. Okay, cool. These 2 now have to be a 4. Or a what? A 6? Yeah, 4 or 6. And the 4 has to go here. Yeah, we've got a 2, 4, 6 triple there, right, okay. That's, we should know what that is. 1, 2, 3, 4, 5, 6. Boom. Because they're here, which makes the 4, the 2 there, the 6 there, the 2 there. That's 6. Yeah, let's become a 4. Let's become a 5 because of that. The last digit in this box is a 1. That's a 4, a 1 there. A 5. I feel like that's what's missing there. Last 2 in this are a 2, a 7, and a 4. I'm actually picking those up nicely. That can't be the 7. That can't be the 2. Got a triple down here. Okay, that's now a 6 or an 8. 6 can't go there, so that's the 8. 6 up there, well that's made that a 7. Made that a 9, that a 7, that a 1, that a 9. Okay, that 7's made that a 2, a 4, and a 7 here, and an 8 there. Okay, I don't know what these shadings are. Is that the only places those can go? Yeah, that's the only place a 2 can go. Now the only place a 1 can go. So the only place a 5 can go. And our mystery digit is 4. Okay. Oh, I just felt like I did that pretty well. Apart from getting this 9 stuck in column 2, row 4 for a little bit. I don't know how to end these, boys.